So welcome to this lecture of machine learning training program, and in this lecture I'm going to talk about more about how to split the data into two. Okay, as we saw in the last lecture in the logistic regression, that how we can split the data into two using a logistic regression algorithm. But in this lecture I'm going to talk about more about how we can split the data, and we'll be digging deeper into the art of splitting the data. Okay, so let's say we are having these 6 points. Now I want to split this data into two parts. So we all know we can put a straight line here, right? We can put a straight line like this. We can put a straight line like this between these two data points. And again, like this line, this blue line will be able to divide these two data set, the whole data into two parts, which is the green side and the red side. But what if I say that there is another line that can also split the data into two in a very perfect manner? Okay, like this. Okay, let's take it to, like, let's say not remove this one, and we can have the unlimited number of lines, but I want to explain you something here. Okay, so we can split the data like this also, right? We can split the data like this also. Is that right? So if we can split these two data into these two lines, actually we can have multiple lines like this. Sorry, not like this. We can have like this. We can have like this. We can have like this. But these are, there are unlimited possibilities. But I want to explain you something here. So let's say these are the two best lines that can divide the data into two. And how will we decide that which line is better? So just tell me by looking which line is better cutting the whole data. Just tell me by looking. Now to calculate this, I'll say that yellow line is better. Okay, but how I can say that yellow line is better? On which criteria I can say that yellow line is better? Okay, so we will be using something known as support vector machines here to know which line is better cutting the data. Which line is better cutting the data? To know this, I will be using the concept of support vector machines. I'll tell you what support and vector and everything is. Just look at the solution for now. So we saw in the linear regression, to know which line is better, or we can say to know how the line is performing or how our model is performing, is by calculating error, right? These lines is our model. This is the one model we have made. This is the one model we have made, second one. And we have to know that which one is better. Okay, so how we do that in the linear regression? We do that by calculating the error. Okay, by calculating the error between the data points, which one is having the minimum error, and that is our model that we want to choose. And to minimize the error, we use gradient descent. But what happens in the support vector machines? Is it will calculate the distance between the lines and the data points. Actually, it will calculate the distance between the data point and the line which are closest to one. Okay, which are closest. That means the points that are closest to that line is going to be our solution here. So let's say these two lines are the most closest one. These two lines are the most closest one for the blue point. Okay, this green and this red one are the most closest lines that exist in support in this particular model to this. This blue model. These 2 points are the most closest line that exist. Okay. And we have another one. We have, let's say, this one, which is yellow model, and we can calculate this. These are the greater one. These are the closest one. Like, we are not considering this. We are not even considering. So I'm going to mark them something like this, that we are not considering things. Okay, let's take it to pen, and we are not considering these for now. We're not considering these. Okay, let me put across. We're just considering the closest point that exists in that data frame, the closest point. Okay, so according to the, let me put it like this. We have the green one. Okay, let's say we have the blue one, and the blue one is having, this is the closest point that we have. Okay, this is the closest point we have, which is this and this. Okay, and also we can calculate this one also. The closest points we have. The farthest one, we are ignoring it. These are the 4 points that we have to calculate the distance. And for the yellow one, for the yellow line, the distance is like this, and also like this, and also like this. Okay, and also like this, right? We can do that, like not this one. Okay, and this one is also like this one. Okay, so we have these points and we have these errors we have. So for the blue one, let's say for the blue one, we are having the errors like these are the errors, and we are going to grab the error like this. For the blue one, let me write error here. Okay, let me write error. Let's take another color not to get confused. So let's say we are having the error. Okay, and for the error blue one, we are having some error for the blue one, right? So we can calculate the error by, like, say this is the line, which is a very small one. Okay, very small line is there, and then we have a very big line, which is this. Then we have again very big line, which is, let's say, this, and again we have very small line, which is this. Okay, let's make the small line way small because they are way small, these are way small. Okay, so we are going to have a line like this, and like this, and like this. Okay, these are the 4 errors we have. And for the yellow ones, what we have for the yellow ones, we are going to calculate the errors. That means this is the little big one. Okay, this is the big one. Again, this is the quite big one. Okay, and then we have this one, then we have again this one, then we have this one, right? These are the error points we have. So these are the error according to the model. For yellow one, this is this, and for blue one, for this is this. Now, if we calculate, if we add these errors, then this error is going to be, which one is going to be lower one? Which one is going to be lower one? Okay, and in linear regression, we calculate the lower error, but in the support vector machines, what we do is, we use some mathematical function here. Let me tell you which one. Okay, let's take a pen, and a mathematical function that is known as, you know that mathematical function already, and that mathematical function is known as min. Okay, min, and we are going to take the minimum of all these errors that exist. Again, we have this min, and we are going to take the minimum of all these errors that we have, right? So according to this, we are going to calculate the minimum of all the errors that exist in this data set. Okay, the minimum of all the errors that exist. So if we put equal to here, and if I'll say that minimum of these error is this one. Okay, and according to the yellow one, we have the minimum error like this. Okay, after calculating the minimum of all the error that exist for a particular model, we have this output, right? And we call them as distance. Okay, we call them as distance. Once we calculate this distance, once we have the idea of this distance, the job of support vector machines is to select the distance that is greater one, that is going to be the larger one. Okay, that model is going to be selected as the perfect one. Like in this case, we are having the yellow one. Okay, in this case, we are having the yellow one. You know, just to repeat it again, that first we will be calculating the minimum of all the errors that exist for a particular model. That, you know, if you have 100 models here, then we're going to calculate the 100 minimum distances for all the lines that exist. Since we are having only 2 lines, so we are calculating the minimum of these 2 lines between that line and the closest point to that line. Okay, closest points. That means these 4 points are the closest points to both of these lines. Okay, the closest point to both of these lines, remember this. Okay, and once we calculate the minimum of them, the model that is going to have the largest distance between all the model is going to be selected. So between these 2 models, the largest distance that exists for a model is this one. That means yellow line is better. Yellow line is better, and this line is not better. Okay, so this is how support vector machines work. And how do we maximize this distance? How do we maximize this distance? We use gradient descent for that. Okay, and we call them as support vector machines. And why we call them as support vector machines? Because we are having, okay, because we are having the supports these data points are working as supports to calculate those. These data points are working as supports here. Okay, that is why we call them as support vector machines. So that's it for today's class, and in the next lecture we are going to talk about more about some algorithm, and this is how support vector machines work. And if you have any question, just tell me in the forum, or you can tell me on my Instagram. Thank you so much. We will meet in the next lecture.
To change your